This is just a quick review of mechanical advantage and some of the topics that we've covered with it. First of all, IMA stands for ideal mechanical advantage, and that deals with distances. DE stands for distance of your effort force. DR stands for distance of your resistance force. As an example, if I have an effort force that is 4 feet from the fulcrum and a resistance force that is 3 feet from the fulcrum, my ideal mechanical advantage would be 4/3 or 4:3. That is 4 feet of effort for every 3 feet of resistance that I get moved. So if I'm pushing an object, 4 feet of my effort going in to get 3 feet of the resistance or the object that I'm trying to move. For actual mechanical advantage, or AMA, we're dealing strictly with forces. The force of resistance is the output force. Force of effort is the input force. So to turn a screw, if I were to, it needs 50 pounds to turn the screw in, and I'm putting in 70 pounds, my mechanical advantage is 5/7. I could also write it as a ratio 5:7. Writing it as the ratio 5:7 means that I'm getting 5 pounds of output force for the 7 pounds of input force that I'm putting in, which is if we actually look at that as a fraction again, 5/7, it's less than 1, and I'll go over what the difference is in the two different types of mechanical advantage. If I have a mechanical advantage greater than 1, then that means I'm putting in less force over a greater distance. If I have a mechanical advantage less than 1, then I have more force over a much shorter distance. To give you an example of a mechanical advantage of greater than 1, let's picture a wall. I have an object that I want to get up this, and it is 10 feet. Now, to lift the object the 10 feet would require quite a bit of resistance, or quite a bit of force. A lot of work to lift that straight up 10 feet. However, if I go and build myself a ramp, this is going to be much bigger than 10 feet. Let's just say that it's 25 feet. But it's easy for me to push an object up that over the 25 feet. So the mechanical advantage of greater than 1, longer distance, much less force that's needed all at once. For a mechanical advantage less than 1, all it's saying is that I'm putting in a lot of force and moving it over a very short distance. The example that we had used before in class was a weight set that's on chains. When talking about both actual mechanical advantage and ideal mechanical advantage, you end up having to talk about efficiency. Efficiency is just the percentage of the work input that is converted to the work output, or how much of it's actually getting through, how much of the force you're putting into it are you actually getting out of the system. So the percent efficiency is your actual mechanical advantage over your ideal mechanical advantage times 100. So let's say, for instance, if I had an actual mechanical advantage of 2, and then I have my ideal mechanical advantage of 3, if I actually put them into the formula, it's 2/3 times 100. 2/3 is 0.66, and that's going to be repeating. If I multiply that times 100, then it's 66.67% efficient, meaning that I lose about 1/3 to something. About 1/3 of the force I'm putting into moving my object of resistance is being lost to friction, or lost to by some other means. So that's the end of the videos covering actual mechanical advantage, ideal mechanical advantage, and efficiency.